Great day, our dear senior high school learners. I am Teacher Tony, and welcome once again to the Kapnayan headquarters. Because we believe that nothing or no one should stop us from discovering new facts and helping people, we're always at your service. I know you will do great as one of my apprentices. That is why let's continue unleashing the saysay at husay ng inyong mga sarili. Everyone is welcome to join us in this episode. Just make sure that you have your pen and paper ready so you can write down what you will learn today. In our previous episode, we learned about the polarity of molecules, specifically bond polarity and electronegativity. We have discussed how to determine the overall polarity of molecules by predicting its molecular geometry. Lastly, we gained knowledge on the applications of the concept of polarity through the mixing of substances, such as oil and water, and the removal of dirt. Today, with your help, let's all be in full force in helping others. And speaking of force, we'll be talking about a special force of attraction that is formed between molecules. Together, let us learn about intermolecular forces and explore the exciting world of physical science. A force may be defined as a push or a pull. Whenever there is an interaction between two objects or entities, force is definitely present. Every time we are walking, pushing a table, stretching a rubber band, lifting a box, folding a piece of paper, and pressing the spray bottle of alcohol, there is force. We may not see it, but we feel its effects. To start our discussion, let us recall the four fundamental forces of nature that governs everything that happens in the universe. In terms of strength, the strongest of the four is the strong nuclear force. This force is the one that holds protons and neutrons in the nucleus of an atom. Do you know that the destructive power of this force was seen and experienced during the World War II, year 1945, on the bombing of Hiroshima and Nagasaki in Japan? Next is electromagnetic force. Sounds amazing, right? It binds electrons to the atomic nucleus, and it basically deals with the attractive and repulsive interaction of electrical charges. It is responsible for some of the commonly experienced phenomena, like friction, elasticity, the normal force, and the force holding molecules together. Take note, my dear apprentices, that electricity and magnetism are closely related, and together they form an electromagnetic field. Little is known about the third fundamental force, the weak nuclear force. It might sound weak, but it is actually involved in the important processes, such as the radioactive decay or the breaking down of heavy atomic particles, which eventually forms new elements in stars and supernova explosions. And lastly, gravity. What comes up, comes down. Yes, gravitational force. It causes objects to be pulled towards the Earth. Gravity ka ba? Kasi you're always attractive and never repulsive. Just kidding. But it is true that gravity is purely an attractive force. Take note also that gravity is the reason why we stay on the ground, together with the planets and moons that stay in their orbit. Oops, wait a second. I have received an email. The email is from Molecular.
Good day! I am amazed and curious at the same time about a sci-fi movie that I have watched recently. I saw how liquid nitrogen was used as a coolant and as a special effect in one of the scenes. It immediately turned into vapor. The effects are cool, literally. But why is it that water, also a liquid, needs to be heated first before it turns into a gas or steam? What could be the reason behind this? Thanks!
Thank you for trusting Kapnayan Headquarters to answer your question, Molecular. Of course, the science of chemistry has an explanation for that. As we all know, matter is made up of particles that are in constant random motion that interact with each other. The interaction between particles and their strength determines certain properties, like boiling point, the temperature at which a liquid boils and turns to vapor. The particles in liquid nitrogen have a different and weaker intermolecular forces that are present in a liquid water. That is why it turns into vapor easily. Let's get to know the intermolecular forces of attraction by watching this video. Intermolecular force is the attractive force or bond between molecules, which is responsible for keeping matter in its solid or in its liquid phase. There are 4 types of intermolecular forces of attraction, or IMFA, that are commonly observed: London dispersion forces, dipole-dipole forces, ion-dipole forces, and hydrogen bonding forces. The first 2 are collectively known as van der Waals force, named after the Dutch physicist Johannes van der Waals. Let's first investigate the weakest type of intermolecular forces of attraction, the London dispersion forces. Named after the German-American physicist Fritz London, this force is present in all molecules, whether polar or nonpolar. Electrons in this case are constantly moving, but there are times that electrons are confined to one end, making it partially negative, and the other end becomes partially positive. What do you think will happen after this? Since there is an equal distribution of electrons, it causes nonpolar molecules to be polar temporarily, creating a temporary dipole or an instantaneous dipole. Have you tried using a saline solution or salt and water mixture to relieve the pain caused by sore throat or mouth sore? Well, every time we mix an ionic compound like salt or sodium chloride and a polar solvent like water, the third type of IMFA is involved. It goes by the name of ion-dipole forces. Ion-dipole forces are the result of the electrostatic attraction between an ion and a molecule containing a dipole. The strength of this force increases as the charge of the ion increases. When sodium chloride dissolves in water, it exists as sodium positive and chlorine negative. The partial negative oxygen atom of water is attracted to sodium, while the partial positive hydrogen atom of water is attracted to chlorine. The last intermolecular force happens to be one of the strongest types. Let's get to know more about hydrogen bonding, a special type of a dipole-dipole interaction. And as the name suggests, this force occurs when hydrogen is bonded to its best friends, fluorine, oxygen, or nitrogen, 3 of the most electronegative elements. This interaction makes the partially positive hydrogen of one molecule interacts with the partially negative fluorine, oxygen, or nitrogen atoms in another molecule. Together, they make very strong polar bonds, just like the water molecules. This is the reason why they have high boiling points and melting points, meaning you need a very high temperature to break the strong intermolecular forces between the molecules. And that completely answers the question sent by Molecular. Due to the weak intermolecular forces between the molecules of liquid nitrogen, they can be distorted easily with a very minimal temperature or even at room temperature. That is why it easily turns into vapor. A very cool vapor it is at a negative 196 degrees Celsius. Pretty cool, right? I am sure you have learned a lot. Help me complete a table that will summarize the key points about each type of IMFA. The first type of intermolecular force of attraction is the London dispersion forces, which are basically present in all types of molecules. In terms of strength, it is weak because temporary dipoles are involved. What is the next type of IMFA? Okay, dipole-dipole forces, which are present in polar molecules. It is a moderately strong type of intermolecular forces of attraction. The third is the ion dipole forces. Can you tell in which molecules this type of IMFA exists? It is present in solutions of ionic compounds dissolved in polar solvents like water. And finally, the last type of IMFA is hydrogen bonding. Hydrogen bonds with molecules containing fluorine, oxygen, or nitrogen. And what can you say about its strength? Yes, it is a strong type of IMFA. The forces of attraction that exist between molecules that comprise matter is attributed to its physical properties, like density, solubility, and the two that have been mentioned earlier, boiling point and melting point. Before we continue, I think we need to answer another query. Michael, a senior high school student who loves taking care of reptiles, insects, and arachnids, have sent in a video question.
Good day, Top Lion Headquarters. I'm Michael, an animal enthusiast. I would like to ask why some animals like the basilisk lizard has an ability to walk on water. Is there something special with their body structure that helps them to do that? Or is there something in the water that permits them to do that kind of trick? I know that you will be able to answer my question. Thank you so much.
Very interesting question, Michael. Thanks for trusting us to answer that wild question. As always, chemistry has an explanation for that. When they are in danger, basilisk lizards run on their hind legs across the water. Their hind legs have long toes that help in increasing surface area to distribute their weights so they can drive themselves on the surface of the water. But why is it that they do not sink? This is due to surface tension, the force that causes molecules on the surfaces of liquid to be pushed together and form a layer. And it is not broken by the large surface covered by their feet. I bet you have probably heard a lot about COVID-19 testing recently. One of the types of tests used is the rapid antibody test. The procedure uses extracted blood sample from a person. A medical practitioner takes a blood sample from a patient's finger using a capillary tube. Interestingly, intermolecular forces also act on this situation, making the contraction and pulling up of the blood sample in the tube possible. This is called capillary action. It is the ability of liquid molecules to flow in narrow tubes or porous material. Liquids, in this case, flow against gravity. The attraction between like molecules or cohesion and the attraction between unlike molecules or adhesion bring about capillary action. The water molecules in our blood are all the same, and they exhibit cohesion, while the attraction between water and the sides of the glass tube is adhesion. Since adhesion is stronger than cohesion in this scenario, the liquid is pulled upward. I hope that the bloody scenario we had earlier did not cause you any fear in our quest for knowledge and in helping others through science. There is so much more to learn, so let's continue. This time, let's talk about another liquid. But first, let's have a quick guessing game. Try to guess the name of the substance that we are going to talk about. This liquid is considered a superfood as it contains water, vitamins, minerals, and enzymes that give energy to the body. It also has medicinal properties. When sealed in an airtight container, it is one of the few foods known to have an eternal shelf life. It does not spoil. And finally, I would say, along with the bees flying around, it is one of the most delicious substances on Earth. Did you say honey? Then you are correct. Honey is one common example of a liquid that is thick and flows slowly. Do intermolecular forces of attraction have something to do with this? Yes, of course. Viscosity is a measure of a liquid's resistance to flow, or in layman's term, the thickness of a liquid. The greater the viscosity of a liquid, the more slowly it flows. Liquids that have high intermolecular forces are highly viscous, like honey, syrup, glue, fuel oil, and lubricating grease. Temperature also affects viscosity. The higher the temperature, the lower the liquid's viscosity, meaning they will flow much easier. All right, how is the flow of our journey so far? I hope you are still feeling great as one of my apprentices. With that, let's test your memory. Can you recall the different properties of matter influenced by the strength of the intermolecular forces? These are boiling and melting points, surface tension, capillary action, and viscosity. Oh, here we go again. I think another video question was sent to our headquarters. Let's check it.
Magandang araw sa inyo dyan sa Capillary Headquarters. Ako nga pala si Edwin at mahilig ako magbike. May tanong kasi ako paano ba ginagawa ang mga bike frames o ang mga batalya? Meron bang specific technology o materials na ginagamit dito para maging matibay na to at magaan na rin? Alam ko may makakasagot sa inyo sa aking katanungan.
Thanks for trusting our team to answer your questions, Sir Edwin. All together now, chemistry has an explanation to that. To answer this question, let me call on our resident materials engineer, Engineer Chad David. He studies and evaluates various materials to improve their performance and creates new ones to help advance technologies or products that are durable and cost-effective. You have learned from Sir Tony earlier that properties of materials are influenced by the IMFA. These are important considerations when we design different materials for various uses. Thus, the properties of the material should match the product's intended environment and should not interfere with its function. For sports equipment like bike frames, composites are used. It is a combination of two materials with different properties that, if combined, produces a material with added strength, efficiency, and durability. Nowadays, aside from aluminum and steel, bike manufacturers use carbon fiber composite materials, comprised of carbon atoms that are linked covalently. Do you know that carbon fiber is 5 times stronger than steel? Yet, it is lightweight. This allows easy movement for the user. It is also durable, which is important since great force is applied when using it. Just like any ordinary fabric, it is woven, then soaked in a special kind of liquid. Afterwards, it is heated, and molded into its desired shape. In our country, bamboo or kawayan is also being utilized as bicycle frames. Bambike has gained popularity because many people are looking for sustainable and environmentally sound products. Just like the conventional materials, bamboo is also durable, resistant to stress and impacts, and can offer a smooth ride as well. Truly a tatak Pinoy that we can all be proud of. Wow! The forces of attraction that exist between molecules, though unseen, really plays an important role in many unbelievable properties of materials that we use. Thanks for sharing your expertise, Engineer David. You're welcome, Sir Tony. I'm glad to be of help to your apprentices. Oh, time flies so fast when we are having fun learning. Did you know that your brain cells have just produced a lot of dopamine? Dopamine makes us feel good. That is why it is also commonly called as the happy hormone. According to studies, you can boost its level by setting realistic goals and finding ways to achieve them. Just like what we are doing right now. You have joined us here in the Capnayan headquarters to better equip yourself with knowledge on physical science. Today, you have learned about the different intermolecular forces of attraction, or IMFA, and how it is related to the different properties of matter like boiling point, melting point, surface tension, capillary action, and viscosity. And with the help of Engineer David, you gained more knowledge on some applications of the concept of IMFA in designing and making various materials that we use. Now, it's time for your assessment, my dear apprentices. Read and analyze the questions and choose the best answer. Which of the following properties is not influenced by the type of intermolecular forces? A. Viscosity. B. Molar mass. C. Boiling point. Or letter D. Surface tension. The correct answer is B. Molar mass. Number 2. Liquids can form a spherical elastic film to minimize surface area. What intermolecular forces are responsible for the formation of this film in water? A. Ion dipole forces. B. Dipole-dipole forces. C. Hydrogen bonding forces. Or letter D. London dispersion forces. This is made possible by letter C, hydrogen bonding. Number 3. When intermolecular forces are high, the boiling point is expected to be A. Low. B. High. C. Dependent on the kinds of atoms. Or letter D. Dependent on the number of atoms. If you answered B, high, then you are correct. Number 4. Looking at the diagram of attraction between two hydrogen chloride molecules, what type of intermolecular force is present? A. Ion dipole forces. B. Dipole-dipole forces. C. Hydrogen bonding forces. Or letter D, London dispersion forces. The correct answer is B, dipole-dipole forces. And number 5. Which of the following materials is used in making bicycle frames that are lightweight and durable? A. Silicones. B. Polymers. C. Composites. Or letter D, aggregates. The answer is letter C, composites. Congratulations for being focused disciplined, and determined till the end. With that, you deserve to be given a badge. I know that you will be using the knowledge you have acquired today in your daily life. For today's reflection, the attraction between some of the intermolecular forces might seem to be weak, just like us humans, don't you think? But you know what? I encourage all of you to acknowledge your weaknesses. There's nothing wrong with that. What is more important is that we work hard in overcoming them. Believe me, from our weaknesses, we can also find strength and greatness. Keep the faith and don't give up. Hashtag laban lang. Congratulations for being focused, disciplined, and determined till the end. With that, you deserve to be given a badge. I know that you will be using the knowledge you have acquired today in your daily life. For today's reflection, the attraction between some of the intermolecular forces might seem to be weak, just like us humans, don't you think? But you know what? I encourage all of you to acknowledge your weaknesses. There is nothing wrong with that. What is more important is that we work hard in overcoming them. Believe me, from our weaknesses, we can also find strength and greatness. Keep the faith and don't give up. Hashtag laban lang. That's all for this episode, and I hope you had a great time learning with all of us here in the Kapnayan headquarters. Join us next week as we investigate the chemistry behind biological molecules. This has been Teacher Tony, and it's an honor to have taught, inspired, and empowered you today. Continue unleashing the saysay at husay ng inyong mga sarili in everything that you do. Till next time, my dear apprentices, bye!